Okay, yeah, thanks everyone. Thanks especially to Simon and Prototype.berlin for inviting me to this talk. Today I'm going to talk about the Stencil, the past, what is happening today, and the future of it. My name is Manu. I work as a software engineer at the framework team, which is the teams that build the open source project, the Ionic framework, and also the Stencil itself. Today we see a Stencil as a tool chain for building reusable and scalable design systems, but it has to be based in future-proof web technology, and I will explain that later. If you know Ionic, you probably can imagine that as a big design system, right? We have 100 components, and then we have to implement the material design spec and also the iOS styles. The problem is that this single, right? Because maybe between different versions there is small changes, but it's pretty much the same thing, right? The thing is that we have to implement it from scratch already 4 times. The fourth is in the next slides. So the first time with the Codica, it was a drag and drop tool. It used the query API. It was imperative. Everything you have to do, you have to use the imperative API of the query. Then we use Ionic 1 with AngularJS, and then finally Angular. So the problem is that today the ecosystem is way more different, right? There is way more frameworks and options, and companies and people use these tools to build real application, right? So as part of our focus and goal as a company, we want to allow all the web developers to use the web to create application, not just the ones using a specific framework. So in the last release, when we start thinking about how to build Ionic 4, we start thinking about something else. We don't want to use a specific framework. So we create Ionic Core. Ionic Core is the set of web components that implement all this design system, right? So when you have web components, you just drop in a script tag in an empty index HTML, and it just works, right? But this is not really how developers and companies build applications, right? They use frameworks. So it was really important for us to make sure that developers feel like home, right? Like they can write automatic code. So here is an example of Ionic Angular. They just import Ionic module, which is an ng module, and they just use it just like a normal collection. But under the hood, they are just web components. And the same with React. But instead, we try to find the patterns that make sense for React developers. So you import the components, and then you just use it. And you have all the features and all the type checking, everything that a React developer, an Angular developer will expect. And same with Vue. So, when you start thinking about this, they are not just components, right? We have to create a design system. And a design system is not only a technical thing. Like a design system is to be used. So you have to make it easier for the actual users of your design system. Otherwise, no one is going to do it. So that's why that's what the Stencil solves. It's not just a tool to create just random components that work, but actually design systems that scale. So in order to do that, we have the concept of output targets. So an output target, okay. So in a Stencil, you declare your components in a declarative way. So there is not really a specific runtime. Instead, the compiler takes all this information, and then you can have different outputs. So for example, some outputs can be bindings for different frameworks, or some output can be a dependency-free script of JavaScript that works in Node for server-side rendering, or documentation, or lazy loading, or just raw web components. So for example, here, it's an example of how you have one single component. In this case, it's button, but Stencil is able to generate different versions for different browsers. So, for example, in here we have up to 8 different files The first 4 are for iOS, the next 4 are for Natural Design. Some are for ES5, which means that browser that doesn't support native modern JavaScript, like native async await or classes and this kind of things. But it doesn't mean that your final user will have to download all these files. It will just have to download one, the best one actually for them. So the focus in Stencil is not to keep adding features and features. I think from a runtime perspective, it's done. We can improve performance and make slightly changes, but the focus is in developer experience. So we believe that when you create a component with a Stencil, it's not a Stencil component, it's a component. It's a web component. The information goes down using properties, and it goes up using DOM events. You have HTML attributes. That's the standard things, and that's done. But we want to have framework level features, like things like makes the developer life easier, like hot mode replacement, a very deep TypeScript integration, fast reveals, docs, everything you can imagine, testing. So for example, here in the documentation of the Stencil config, you will just add type docs, and it could generate a README file. So you can actually host your documentation in GitHub. You don't need anything else. But also emits a JSON file with all the docs, all the information about your components, and you can build, your website with that or anything. So 2 months ago, actually, here in Berlin, we announced Stencil 1, which is it's a consolation of the API, because Stencil is not really a new product of our company. It's something we built for us. It's something we built to stop, re-implementing Ionic every 2 years because a new framework comes, right? So Stencil 1 must. So we find out that a lot of companies start using it, big companies with kind of different use case, but all of them trying to create design systems. So the Stencil Stencil 1 was this effort to make sure that we can cover all the use cases. New compiler architecture, server dependencies I will talk about later, and just faster and smaller runtime. So when I talk about dependency free, it's actually really weird because when you run npm install, you probably find hundreds of things that you don't really know what's going on, what's coming. But when you do that with Stencil, you don't. You just find the Stencil and TypeScript. And that's good because TypeScript is actually dependency free. So that kind of feels like part of our philosophy. The TypeScript team has the same mindset that it's important for the future proof of a company to know the code that is actually running. And even though when you generate a component with the Stencil, they don't have any dependencies. So think about when you create a component with Angular, you have dependency on one specific version of Angular. Same happens with lead element, React, any possible framework. You have a dependency in this specific version of specific framework. But that's not the case with the Stencil. When you output, it's completely dependency free. Even if npm goes to hell and the internet is gone, your components work because they don't have any dependency, not even in Stencil. So all of this comes to, we can generate an 87 bytes hello world compress. You might say, well, this is a very artificial example, and it is, but it shows the power of what a compiler can do to remove things that are not needed. But for example, to do MVC, which is pretty much like industry standard for testing frameworks, it's just 2.4 kilobytes. And we are really proud about what we can do with all of these. So to put it in context, this is right now. So this is Angular Ivy, actually. The Angular today is around here, more or less. So yeah, we are really proud about it. The next thing I want to talk about is Stencil DS, which stands for Design Systems. The focus of a Stencil open source is design systems, right? But sometimes there is, how do you say, like more specific requirements for bigger companies. So we are trying to help to help them. So Stencil DS is a pay service that includes support and advisory. That means not only that if you have some problem with the Stencil, we'll try to fix it with priority, but also how to build and how to maintain a big design system. And we believe that we are experts in that. And not only build it, but actually millions of developers are using it. We can have the framework bindings that we use in Ionic for your own design systems. We have Playground, which I will show later. Automatic documentation site generation, which is pretty much what we develop for our own Ionic docs, but for your own design system. Usage tracking, which is a really interesting thing. It came from conversation that we have with some company, that they actually wanted to know how their design system is being used within their company. So usage tracking is not really tracking for the final user, but for the users of your design system. And this only works in dev time. So if you imagine a big company where you have a small team building a design system, and then across all your company you have hundreds of different teams using your design system for different applications. With usage tracking, you can know how your developers are using it, what properties they are using, what kind of data, what kind of issues, the problems they are having. Visual test regressions, I will show later. Per component versioning, I think is really interesting as well. It's you have one collection, but you can have different components in specific versions, which is something that usually big companies require. And training, we have opportunity for even on-site training. We can just someone from my company goes to your office and they will try to explain Stencil in the best way. So for example, for the docs, this is an example of what we can do. It doesn't only document your components, but the design system. We try to accommodate both. So this is a system for both the designers and the software engineers. The playground, it's something really cool. It's part of the documentation side, but it's a way that the users of your components can experiment with it. They can change. They can see all the properties, and they can toggle things and see how they change. And also the usage, which is we want to integrate with a storybook. I think storybook it's called, or storyboard. Storybook, right? So you can have all the usage declared in a storybook-like way. So it can be they are useful for testing, but also they appear in the documentation website. Visual testing, Diff testing, which is something that we apply for our company. For example, here we have we pull request or some commit saying that it updates something, and you can check and you can see what actually change in your tests from a visual point of view. The roadmap for open source are different things, and this is a little bit technical, so I don't know if anyone doesn't know about Stencil. Maybe this is a little bit like what I'm talking about, but I think it's interesting if anyone here knows about. We can talk about that later. We are getting involved in the standardization of CSS modules, and when I say CSS modules, I don't mean the ones in React. So in the left, it's how you have a component and you import some styles, and in the right is what we want to make it. How it's a new API. So pretty much the same, but you import the CSS and then you use it. This is not a breaking change, okay? So because it's part of the design of a Stencil, we don't want to introduce breaking change, so it's fine. Here's another example. For example, we have one component, but we have two sets of styles. So for example, this will be interesting for us in Ionic. We have a material design, MD, and iOS. So you can have, this is an object, material design in iOS. It's also useful to have global styles. Let's say you have something that you want to share across all your components. You can just pass it there. And this is done in a very optimal way because it's using constructible style sheets under the hood, which actually reuse the same. So does anyone know what a constructible style sheet is? So a constructible style sheet is it's a way that it's an API that the browser have, so you can parse and have the representation of a CSS just once and once in memory, and then you can use in different places across different SAO DOMs or different components. So when you have that, you are not really even if this global stylus is huge and you use it in 100 different components, it's just going to be once in memory. So this is really efficient. And also it's very cool because you can actually access the styles variable and you can play with it. And I think this opens the world for other developers in the community to play with it and see if they can generate the styles dynamically or wherever they want. So it's a single API for CSS. It's CSS and duplication out of box. It will work better without the Stencil. I think this is a next focus. We want to make like a Webpack plugin of a Stencil. You don't really need the Stencil to compile a Stencil components. Extendable, you can build on top of it. And it will be eventually standardized. So we're working, so this code here actually works in the browser without any compiler, any boundary or something. If you're interested, here is conversations going on. The next is the compiler API. So right now it's a Node thing, right? We have a CLI, and that works only there. But we want to make something different. We want to have a compiler MGS, which is something that will work in any place. It's just a JavaScript file. So we want to implement Node CLI, but also a browser REPL. I don't know how to say that word. And then maybe it's something custom. This is, let me show you. So for example, here, using that technology, we can have the CLI, but also this is also a request that came from people from Stackflits and Code Sandbox and other like online editors that wanted to add support for a Stencil. And we found that we are too much coupled with the Node APIs. So we are starting this effort to make the whole Stencil compiler run in the browser. So this is some 9-inch reference over here. The APIs look something like this. You create a compiler with some config. This config object will be like the one you have in the Stencil config TS. It's just an object with all the configuration. You can have a single build, which will write everything into the file system. Or you can have a watcher, which will have incremental build in the most efficient way. We are also working to have a fast incremental build, even faster. So very recently, TypeScript 3.6 was released, and that introduced a very cool concept where all the builds are incremental, even the first one. So the idea is that we can have type checking will be incremental. When you stop the process and you start it again, it will be incremental, so it will not take 4 seconds, but 100 milliseconds. And actually for our early testing for Ionic Core, which is 100 components, just changing something in one component, it takes from 10 seconds to 100 milliseconds. So even for very big projects, it will be really fast. This is important because we are working with companies that they are even bigger users of Stencil than us. And they have big design systems with, I think, the biggest one is 500 components. So it's really important to make it fast. And I think we have an architecture where all the components are, they don't have dependencies between them. So it's really fast, and we can have a lot of optimizations in the build process that few people can. We also have a new custom elements output target. And what this really means is that if you have been using a Stencil, you know that the main output target is one that defines all your components in the page or in your collection, and it will download the components when it's actually being used. So you can have 500 components, and if you remember these slides from the very beginning, this one here, this slide is not registering all the 100 components of Ionic. It's actually really small. And only when this component is actually being used is when it's actually being downloaded. So it happens out of the box and it works in all the frameworks. So this works really well, but some companies still want to have raw web components. So we will have an output target that extends from HTML element. It will not have lazy loading. It will not self-register the components, and it will work better with Webpack and Rollup. So this is an example, for example. This is just an ion toggle from Ionic. You use the custom elements API to define them, and you can actually choose a different name. So it's not really ion button, but my toggle. Sorry, toggle. Yeah, and I think that's pretty much it. If you want to give it a try, just go to stencilgs.com, or just open your terminal and type npm init stencil. You don't need to install anything, I promise. Super fast. So yeah, thank you. Thank you so much. Well, I don't have question slides, but if you have any questions, please go ahead.
I really like the idea of the CSS modules and the compiler API. And my annoying questions have any roadmap, or what's the plan for progressing with it? So the main problem right now, and this why I mean the Chrome team is on board with it, but the problem is that this API depends on constructible style sheets, which is this thing, like this API that you can actually construct a style sheet without using the DOM. And the problem is that Safari, for example, and Firefox is not, they want the API, but they are not okay with some of the details of that API, and that's the base for building this other one. So I think they are working right now. I think that also the focus with ESM imports is to, I mean, there is actually one spec for loading JSON in the browser, JSON files directly without, and everyone is on board. So pretty much everyone's agreed that ESM modules should load other things that not just JavaScript. So this will eventually happen, but yeah, there is some details right now. So it doesn't, I don't really know how much it can take. Maybe it's, you know, one afternoon with beers and everything is resolved, or it could take years.
Historically, Ionic and I guess also Stencil was used in combination with Angular, but you placed React quite prominently on your framework slide. Can you gauge how many other frameworks are already used in combination with Stencil?
So any framework really works with the Stencil because they are just web components. So I mean, at some point in the React code base or in any framework code base, there is a document create element and then the name of the element at some point. So that means that they already use the web components API, even if they don't want it, you know. So they already work. The thing is that this feature that we want to, like this idiomatic, like make it easier for the framework developers, like they feel like home, it's something that we have to do it manually right now. We are automating the process with the bindings. And right now we will support React, Angular, of course, and Vue, which I think is the biggest ones. But for example, things like React, it doesn't really need, it feels like very natural today. So it really depends on the framework. Some frameworks work really well with web components without anything. So in that ones, we don't really need bindings.
I've got a question. The question is, my company switched from Ionic before using React to Stencil. So far, we're very happy with the decision. Well, one thing I don't understand is the API for developing a Stencil app is quite similar to React. In fact, it's almost like a copy-paste with some adaptations of React. Correct me if I'm wrong, I'm not that experienced. Wouldn't it have been possible to stick with a fully React API, since they're so similar?
So they look similar. I think they look very similar in the template, right? Because they both use GSX. The fact that we use GSX in Stencil today doesn't mean that we will not support other template renders. Because it's not really the point of a Stencil to have a specific template system. I think GSX is a good one, and it was easy to get started. But then there is other difference, a big difference actually. The event system in React is custom. It's not really using DOM events or anything like that. Then React doesn't have the concept of HTML attributes, and pretty much any data you pass to a React component is dynamic. You don't really specify how many props your React component have. You can just pass anything, right? But in a web component, it doesn't work this way, right? You kind of have to specify which are the HTML attributes that you have and other things. So that's why we have a class. It's kind of a mix with Angular, right? With you have the decorator prop. It's kind of a mix of Angular and React. I agree. We take the things that we want from each other, but it's not something that we can just use React. It's not, in the details, it completely breaks. But yeah, we get some good inspiration. We have Angular lovers in our company and React ones, so we try to get everyone in a meetup and in a room and try to come up with an API for a Stencil.
I have a quick question. Stencil DS looks very neat. Could you share maybe some insights? How many peeps at Ionic are working with other companies at it, or how many companies contacted?
How much does it cost?
You will have to. I'm not sales guy, but I don't know. So I think in the Stencil side we have some that I can talk about. Obviously, this kind of topics are problematic, like legally complicated, right? But I think the ones that we have in the site, they are actually paying users, and they agree that they share in the site, right? But we have bigger ones. And actually, the one that uses the most components, it's something that there is actually one company that everyone has a device. Pretty much everyone has a device and a watch as well that uses it. But we can talk about it. Any other question? Done? Okay, yeah, thank you.